Hello everyone, it's me Nirjal, undergraduate computer engineering student here at Kathmandu University. Last month, in the month of July, I was involved in a research in the field of Neutrosophy. So talking about Neutrosophy, it's a new philosophical concept of mathematics, and I was pretty amazed by it. So basically, when I used to think about computers, I always used to think it as ones and zeros, but when it comes to computing a real life events, it needs to be computed in a gray area, right? And basically the fuzzy set or the Neutrosophic set is whole about the gray area that we can find in computers. Basically, I'm going to explain the same thing in this video. So first of all, I'm going to talk about the fuzzy set, and then I'm going to jump into intuitionistic fuzzy set. Then I'm going to relate intuitionistic fuzzy set with the Neutrosophic set, and yeah, that's all. I just wanted to share this with my audience, and this is just me making a random video. So a small disclaimer before starting a video. So in this video, I'm the only one who has done a fact check. So before directly jumping into the conclusion, please read some research paper. And yeah, I have linked two research papers in my reference section at the last of this video, so have a look there also. So what I'm trying to say is not fully trust me on these concepts. So I have prepared a small presentation on the field of Neutrosophy, so I'm going to just explain you guys it. I guess it's going to just take around another 10 minutes or so let's start. So let's start with Neutrosophic set. So as I have previously mentioned, it's a new philosophy of mathematics. So talking about the general computing, we think about it as either 0 or 1. So here in this graph, you can see this is the 0 area and this is the 1 area, or black area or a white area, right? Talking about representing it in a real life scenario, let's take an example of a weather today. So uh, it can rain today as it can rain today or it cannot rain today, right? So there are two crisp values. So crisp values are the true output, and the probability of, so it will rain today one is one crisp values and it won't rain today is another crisp values, right? But talking about the real life scenario, they are not always 0 and 1. So basically, rather than representing it in black and white, we represent it in a gray area, right? As I previously mentioned. So the pro so rather than just claiming it would rain today or it won't rain today, in news weather stations we get the probability values, right? There's a 25% chance of having a rain today. And talking about the real life scenarios, most of the real life scenarios are represented in this way. So to compute this type of mathematical equation, uh, the introduction of fuzzy set was done. So in fuzzy set, what we do is, as I previously mentioned about the rain thing, uh, the true output is called the crisp functions, and the crisp function is linked with the membership function. So membership function, we can also say membership function as the truth probability of happening that crisp value. For example, in this example of 25% rain today, the raining was the crisp values and the probability or membership function was 25%. So that's how we can represent a fuzzy set, right? Only here you can see some examples of fuzzy and crisp set. So basically these clear boundaries. So till here it's 1, it's a polygon. Till here it's 0, it's not a polygon. So this is how we represent a crisp values. And in fuzzy set, here it's a probability 1 of being a polygon. Here it's 0 of being a polygon. But in this blurry area, it's the probability of the point being in a polygon, it's between 0 and 1, right? It's not completely 1 and 0, right? So I guess you can better see this from this example too. So here, if we had to represent this scenario in a digital computer, we'll have represented it from like a step functions. For example, let's assume this point as 50 and let's assume this point as 70. Then if we had to represent it in a digital computer, we'll have said that from less than 50 it's cold, from 50 to 70 or 80 90 it's warm, and from 80 90 to like higher temperature it's hot, right? But in fuzzy set what happens is we represent like a certain area with a membership function. So here below 50 it's cold, it's true. But above 70 it's not cold, that's also true. But between 50 and 70 there is a gray area. There has a membership function or a truth value. That means like in this 60% temperature we can assume that like there is 75 percentage cold, right? So that's how the fuzzy set is represented, right? Only like after the fuzzy set was once introduced, there were many research on the field of fuzzy sets, and there were many extensions on it. So in this video we are going to talk about the intuitionistic fuzzy set, as I previously mentioned. So intuitionistic fuzzy set is one of the another field of, or we can also say a type of fuzzy set, and we are going to explore that because it's closely related with Neutrosophic set. So talking about intuitionistic fuzzy set, it's a fuzzy set with the crisp values. So every set needs to have a crisp values, right? So it also has a crisp values, but with the membership of degree, it also have the hesitancy and also the non-membership function, which means so basically there is certain percentage of the thing being true, and there are certain percentage of the thing being false, and there is a certain percentage that uh, there is a certain percentage where we cannot say either the value is true or false. So that we can represent as uncertainty. So in intuitionistic fuzzy set, we expand the normal fuzzy set with hesitancy and non-membership function. So also another thing that we need to consider in intuitionistic fuzzy set is that in classical fuzzy set, the false value is always equals to 1 minus truth values. However, it's not same in intuitionistic fuzzy set. And the intuition another thing is that in intuitionistic fuzzy set, the hesitancy or uncertainty value is the percentage of like the data where we can where the data is like any or not determined, right? So that's the main thing that we need to think. So mathematically explaining, so if mu be the degree of membership function or the truth, and v be the non-membership or false, and pi be the uncertainty or hesitancy, then pi should always be equals to 1 minus mu minus truth minus false. And another thing is that in our classical fuzzy set, uh, mu plus truth plus false was always equals to 1, but in intuitionistic fuzzy set it should not be always equals to 1, so it can be between 0 and 1. So from that we can also get the uncertainty or hesitancy value. So for example, in a real life scenario, for example, if the sensor has certain inaccuracy and some values lies in that inaccuracy, then the false reading or the faultiness of sensors can be considered as the uncertainty. So basically in an intuitionistic fuzzy set, it's 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 the representation of uh, it's a representation of like the indeterminate value that are caused by the external factors. So that's how I am being understanding intuitionistic fuzzy sets, right? So again, to be clear, as I previously mentioned, in intuitionistic fuzzy set, the set has a value of uncertainty or indeterminacy. That means the error caused by the external factors, or what can I say is, okay. So let me give one example. So if we have like a Excel sheet with name and pass fail as true and false, है ना? आणि the true means membership function, the false means non-membership function, but there can also be a values that are an a which are caused by the mathematical errors, right? and those Na are represented by uncertainty in intuitionistic fuzzy set. And talking about Neutrosophic set, it's a generalization of intuitionistic fuzzy set, and it was the idea proposed by Florentin Samarande in 1980. He's a professor in University of Mexico, and like he has like 2000 or more papers in Neutrosophy. But so you can like take a great reference from his articles about Neutrosophy. So in Neutrosophy, what we do is like in intuitionistic fuzzy set, it was the error caused by the system, or it was something that was indeterminate, right? But in Neutrosophy set, the indeterminacy is caused by the inconsistency of values. So that can also be seen here. So also the story behind Neutrosophy is that it was introduced from the Latin word neutral, and the Neutrosophy set majorly looks around the neutral part of the scenario rather than the indeterminacy. So that is the main difference between the in intuitionistic fuzzy set and the Neutrosophy. So that's the thing that we need to be clear, right? On the talking about the Neutrosophic set, we can see here there is one example of the same raining thing. So the probability of raining can be truth, the probability of not raining can be false, and the probability of like raining and not raining. So that means both of the event occurring at once are not occurring at once, but the neutral scenario between true and false can be represented by Neutrosophy. And in intuitionistic set, these three variables, truth, false, and uncertainty, were basically like constrained by these two were constrained by these two equations, right? But in Neutrosophy, all three values are not constrained by anything. So all those three values can be between 0 and 1, and that's the thing that we need to consider our Neutrosophy set. And let me give some example. So basically, the American election is close, right? So voting on Democrats can be considered as true. I'm not actual Democrat, but just giving an example here. And let voting Republican be false, then like being neutral or not participating in voting itself can be determined as indeterminacy in Neutrosophic set. So that's what the neutral scenario is, right? So that this is one example of Neutrosophic set to understand actually about this. And similar in the case of Schrodinger's cat, so the quantum bit being wave, the quantum bit can also be represented as Neutrosophic set indeterminacy, or in Schrodinger's cat equation, the photon can also be particle or wave, right? So that scenario can also be represented as the Neutrosophic set. And so basically, I guess you guys got about what Neutrosophy is. So basically, Neutrosophy is all about like including the neutral values in the equation of mathematics. And because of this, and this is awesome. And these are the references that I have like majorly taken the points from. And like if you guys want to read more about Neutrosophy, you can like just search Neutrosophy and read papers from Samarande. And there's another author named Asbrami who also has around 1500 papers on the field of Neutrosophy. So yeah, do read it. And yeah, so talking about my research, it was about something related to network, and we implemented the Neutrosophy to like resolve the network. And it's not yet published, but once it's published, I'm also going to make a video about it. So basically, this is what the concept of Neutrosophy is. And I want to thank Sangam and Dr. Professor Susan Jha for guiding me to the field of Neutrosophy, and it was amazing learning the Neutrosophy. And similarly, if you guys have any questions about Neutrosophy, I guess I won't be able to like answer them all, but I'll try to. So do leave anything about Neurosophy in comments if you have. And that's all. Thank you.